We introduced HFGI 3D, which is high-fidelity 3D GAN inversion by pseudo-multi-view optimization. Given a single input image, HFGI 3D can synthesize consistent novel views for the input, also preserving specific detail of the input image, like tattoo and freckles in these two examples. The motivation for our work is directly utilize 2D GAN inversion method to 3D GAN while least 3D collapsing during the optimization. So we design our method to train with pseudo-multi-views, which helps to keep the 3D availability of 3D GAN when optimization. HFGI 3D offers a multitude of applications which we hope will contribute to the community. We introduced HFGI 3D, which is high-fidelity 3D GAN inversion by pseudo-multi-view optimization. Given a single input image, HFGI 3D can synthesize consistent novel views for the input, also preserving specific details of the input image. The advantage of the paper becomes evident through a clear comparison with other sorter methods. The image-specific details, such as the tattoo, can be preserved very well with our method compared with others. Here is another example of celebrity. Our method keeps the most representative facial feature of Megan. Compared with other methods, the identity in the novel view is much more similar with the original. And here is another example of the unusual face expression. The proposed method can still generate high-fidelity novel views for this case. The motivation for our work is directly utilize 2D GAN inversion method to 3D GAN, while least 3D collapsing during the optimization. We can see that as the optimization iteration increases, the reconstruction quality of the input image becomes better. The texture on the face becomes more and more clear, but at the same time the estimated geometry becomes more distorted. So this motivates us to add more regularization during the optimization process. We observe that during the optimization, the latent is first overfitted to the general shape, and then the textures gradually appear. We can see that for the second clone image here, although the texture is not rendered correctly, but if you stack the images, you can find that the general shape already matches. The similar observation was also found in the 2D image, like the DP image priors. So we can early stop somewhere around here to get the initial geometry. Based on our observation, we propose a pipeline comprising two procedures, pseudo-multi-view optimization and optimization. Additionally, the pseudo-multi-view optimization step is divided into visible part and occluded part. In visible parts, the latent code WVs is early stopped to get the initial geometry. With this latent code, we can extract the geometry and get the texture mesh. We then render the mesh in a novel view to get the visibility mask MV and visible projection VI, which preserve the texture in the novel view. For the occluded parts, we use the generative ability of the network to impend. The main idea we want the inversion to do is going back into the average latent space, so that the 3D GAN can generate it perfectly. We use the difference map to occlude the out-of-distribution texture. With the visibility map VMV, visible projection VI, and estimate impending OI, we can get additional supervision XI. Then the final step is optimization. For each iteration, we take the original input and render pseudo-multi-view for the regularization. Then reconstruction loss is one from the original and the other one from the pseudo-multi-view. The reconstruction loss contains L1 loss and perceptual loss. Here is the quantitative comparison. The PSNR, SSIM, and LPIPs of our reconstruction all outperform the baseline. For the 3D consistency, we follow the evaluation method of Stelner and also provide identity loss to compare. But still, it is hard to evaluate the 3D consistency very accurately, so we also perform an additional user study to show our reconstruction quality is better. As method is essentially a GAN inversion structure, we can perform 3D-aware image attribute editing, such as adding smell and changing age, changing the gender, and adding glasses. We can perform another type of editing by directly paint on the input image. And the 3D-aware stylization can also be performed. The ablation for our paper is straightforward. Without the inpainted occluded part, we can observe incorrect shapes for the self-occluded regions, and without the original textures, the inversion tends to generate smooth results, and most representative features of a person can be lost, and the identity cannot be preserved well. Finally, I would like to share some current failure cases. Most failure cases are due to the wrong estimation of the geometry. Another disadvantage of the proposed method is the speed, because it is an optimization-based method, so it takes several minutes to optimize one image. The future direction of this paper can target on better geometry for extreme poses and fast inference.